Hello and welcome back to the lecture series on algorithmic problem solving. This video is about bit manipulation. Let us understand what is bits. Bits is the lowest language understood by the computer. So let's say that a program is been written and that is compiled and converted into assembly code, and this assembly code language is converted into a machine level language, which is generally in the form of zeros and ones. These zeros and ones are known as bits, and these are understood by computer. Computer understands in terms of bits. Computer. So here in bit manipulation, we will be working on how to operate on bits and look at what are the properties of the bits. First, let us try to get an idea of how to represent decimal number in binary form. And let us say that the number is 27 in decimal form, which is of base 10. So in form it can be written like 10 power 1 plus 7 into 10 power 0, right? Similarly, this number can be represented in binary form in such a way that it can be written like some values in the power of 2. Here the base is 10, hence power of 10 is considered. So power of 2 plus some value into power of 2 into n minus 1 and so on. This is how it will be represented in a binary form. But before that, let us see how to convert this number, decimal number, into a binary form. So we know that while converting decimal number, we divide by 10 to get the result. Similarly, here 27 will be divided by 2 and will keep on dividing until the number is either 1 or 0. And here the remainder or whatever will be represented. Here it will be 1, 13. Then again it will be divided by 2. Again the remainder will be 1. And this is 6 times. Here the remainder is 0. And 6 will be divided by 3 times. Then 3 will be divided by 2, leaving a remainder of 1. Now how to check? Now we have written this. Now whether to go from top to bottom or bottom to top. Here best thing is, since remainder is either 0 or 1 in the last step, so we should follow this direction to write this number in decimal form. One has to go 1, 1. So 27 can be represented in binary form as 1, 1, 0, 1, 1. And in case you want to validate whether it is 27, now this can be represented as 1 into 2 power, and one can check from 10. Here how many digits are there? 2. Here the 10 power n minus 1. So the number of digits minus 1. Here number of digits are 2, 1, 2, 3, 4, 5. So this will be 2 power 4 plus 1 times 2 power 3 plus 0 times 2 power 2, 1 times 2 power 1 and 1 times 2 power 0. Let's see, this is the sum of 1 times 2 power 4 is 16 plus 8 24, 2, 26 and 27. So this is correctly represented, and this is how the computers will understand. So computers, whenever any program is written like int stored in some variable, let's say a 27, so at some memory location a, at some memory location, let's say x, here a is stored, and this will be represented like 11011 27. So this is how machine is able to understand. But what if the numbers are negative? Let's say the numbers are minus 27. How is it being represented in base 10? Let's understand that. So for base 10, it is being represented like 27 plus 3 times 10. So this is how it is being represented in base 10. Now in base 10 it can be represented as minus 27, but the values that a computer can understand are only 0 or 1, and there is no negative number, like no negative of 1, negative of 2, not there. Hence one should be able to convert this number in 0 and 1 in such a way that negative numbers are also interpreted correctly. So let's say 27 can be represented like, this is the representation for base 10. Now let us try to convert this number into decimal form. For that, one need to take 1's complement of this number and then add 1 to this number to get 2's complement, which will be representing negative number in binary form. So what is 1's complement? Just flip bits. So let us consider 27, where the value of 27 base 10 base 2 is 11011. Now just flip the bits to get 0 0 1 0 0. Operators are and, or, not, then XOR followed by shift, by binary shift, either in left or in right direction. Bitwise AND is written with a symbol of ampersand, or is written with a long slash, not is written with a tilde, XOR is with a power exponential, and binary shift or left is written with and right shift this way. Let us have a look at the properties of this operator. let's say the two numbers are A and B, and the binary representation are written, so 0 0 0 1 1 0 1 1, and let us do A and B, A or B, and A XOR B, and not of A. So what AND property says that whenever both are 1, the value will be 1. Remaining all the cases value will be 0. For OR, in case both the values are 0, in that case the written value will be 0, and all the other case value will be 1 1 1. XOR, for XOR, only check the bits where the flip has taken place. So here, while comparing A and B, no flip is taken place, and while comparing A and B 1 1, no flip has taken place. So in that case, the value would remain 0. Remaining all cases, the value would be 1. Here 0, here flip has taken place in B, and 1 in A has the flip in B, so that becomes a value. So for that, the XOR will have the value 1 1. And not of it, A is just flip the bits. So here 0 will be flipped to 1, and 1 will be flipped to 0. That is how this operation works of data types and its size, because that will help us to understand better for the shift operation. For that, int byte is 1 byte is generally 8 bits. One store consists of 16 bits. Short is a data type similar to int, but the size of the data type for this is 16 bits, whereas for int it is 32 bits, and long it is 64 bits. For float or real number, which is 32 bits, double has 64 bits, character has 8 bits. These are some standard data type size set by the compiler, but slight variation in bits can take place. Like some compiler may use int as 16 bits, some may prefer to use 16 bits for short, and for long it is fixed, but for int it may vary. Like some compiler will prefer to use 16 bits, some may prefer to use 32 bits, so depends on the compiler as well. Now we have got the idea of the data type and its size. This will be helpful to understand the idea of left and right shift. For that, let us say for left shift, this is operand 1, and check the symbol. Here the direction is on the left side. Here the direction is on the right side, and here the direction is on the left side. So this is the left shift, where operand 1, left shift operand 2, and this is right shift. Operand 2, This is representing right shift. See the direction of arrow, and here see the direction. Here it's on the left side. Left shift. Now how does this work? Let us say that 27, which is 11011, and considering the data type sort, let's say sort of A is 27. So 16 bits are required for that. So let us consider 16 bits, out of which 5 bits are 11011. Remaining all bits will be 00. This is 12, and here it will be 11011. This is 16 bits, and this is the value of A being represented in binary. Now here left shift by 1. So you just left shift by 1, and this all values get left shifted by 1. So whenever a shift takes place, you can see here, let's see here, the power would be 2n minus 1. Here power would be 2n minus 1. So there is a multiplication by 2. So this will be unchanged, 0 0 0 0 0 0 0 0 0 0 1 1 0 0 1. Now what is left? Something has to be added. Now here the value gets 0 gets added. This is left padding by 0. So this becomes, so whatever number is there, A will again be, will have the value of 34, because A is left shifted by 1. Now let us consider the same example where A is 27 and A is right shifted by 1, and same data type sort, and these are the binary representation of the variable A. Now right shift, and similar example, let's say this value is 2n minus 1, and when you right shift, the value decreases by 2. You can check here. So this gets divided by 2. So this is basically 27 by 2. Considering that it is a type of int, it will return 13. And one can check this. So this will have the, here padding takes place on the right side. Right padding by 0. And the value will be, this one will be deleted, and here the values will be 1 1 0 1, and remaining all will be zeros. This is how this A will be represented on right shift.